Okay, so in this, we'll continue with some more questions on using rules of inference to proving that a set of arguments is and the conclusion is valid using a set of premises, right? So this is when you have to when the conclusion that you have to make is just one proposition like Q or T, then you can just follow. I mean, you can continue without making any assumptions from the beginning. Now, when you have, like in this case, right? So here, if I just list down the premises, it looks like this. Looks like this: P and T implies R or S, right? And that's the first premise. Second premise is Q implies U and T. Third premise is U implies P. Fourth premise is not S, and the conclusion is Q implies R. So, when you have a conclusion like an implication as a conclusion, right? Like in this case, you can start with an assumption that Q is true, right? The reason is for that implication to be true, we only need to know whether when Q is true if R is true, right? If Q is true, then R has to be true. So if we start by assuming Q as true and if we can reach a conclusion that R is true, that's enough. Now we don't have to consider the case where Q is false, because if Q is false, then Q implies R is anyway true, right? So we only have to worry about this case. So that's what we'll do. We'll assume Q as true, right? So okay. So let's start the so first I'll assume that Q is true. So that's my assumption. Now I have to look at the uh, proposition statement that involves Q, so that I can some apply some rule of inference. And I look at the second statement, right? It involves a Q. So I just write that. So Q implies U and T. So here I'm using the premise, right? I'm using this premise number two, right? Then the third step is now Q is true, and I know that Q implies U and T is true. So I can use modus ponens to conclude that U and T is true, right? So I can write modus ponens using one and two, right? Now if U and T is true, I can use simplification, right? So here I have this third step. If you look at that, uh, if you look at the third step, right? Third premise, it says U implies P, right? So from U and T, I can conclude that U is true, right? Because that's simplification rule uh, from three. Now five, I can use that premise number three. So U implies P. That's premise three. Now six. Now U is true and U implies P is true. I can conclude that P is true, right? So that's against modus ponens using 4 and 5. Now, if P is true, now we'll have our goal is to prove that R is true, right? Okay. So now look at where we have R. We have R in this first premise, right? Now, in that first premise, I already know that P is true, right? And then from 3, I can also simplify and write T is true, right? Because when U and T are true, both U and T have to be true. So again, simplification from 3. Now, what I have now is both both P and T like are true, which means I can conclude that P and T is true, right? So I forgot the name for that rule. I think that's resolution. So you have to write the rule using 6 and 7, right? And then the ninth step then would be I'll write this properly. So that says P and T implies R union S. Now I know that P and T is true, right? So I can use modus ponens to say that R not R or S is true. So again NP using 8 and 9. Now look at 11. I can use this, right? Because my goal is to prove R is true. Now I know that not S is true, right? So not S is true. That's premise 4. Now if not S is true, right? If not S is true, which means S is false, and if R or S to be true, R has to be true, right? So I got R as true. So now I started with the assumption that Q is true, and then I've reached the conclusion that R is true, which means Q implies R is true. So that's the proof for that.